Hi kids, welcome to Unit 2, Lesson 1. Some of the information you're going to be hearing in this lesson might be a repeat of what you remember from Algebra 1 because it's so important we need to spend some time going over it one more time. So, the first thing I want to talk to you about is what the definition of a function is. A function is any rule that assigns exactly one output or y value for each input value or x value. These rules can be expressed in different ways, the most common being equations, graphs, and tables of values. We call the input variable the independent and the output variable dependent. Now, I like to think about this as thinking about a map where the inputs are the people and the outputs are the birthdays. So, this map here are the inputs and the outputs. And if you think about it, Alex might have a birthday of August 5th, Ben has a birthday of January 5th, and maybe Callie has a birthday of May 3rd. So, I'm sorry, January 15th I meant. But as you can see, this is a function because Alex is in August, Ben is in January, and Callie is in May. And that's okay, that's a function. But what you don't realize is that it could also be a function if Ben and Alex share the same birthday and Callie has a different birthday. So if you think about it like this, then Ben can also have that August 5th birthday and Callie can now have the January. This is allowed. Your y values or your outputs are allowed to repeat as long as your inputs do not repeat. Now, consider what would happen if we had Alex having August 5th, Ben having January 15th, but also Ben having May 3rd. Is it possible for two people to have is it possible for one person to have two different birthdays? So can you have Alex being August 5th and then Ben being January and also being in May? And the answer is, of course, no. This is not allowed. You are not allowed to have those x values repeating in a function. I always think that's a really good analogy of remembering what a function is. So you might want to pause for a moment and take some notes on this. Define what a function is and use the analogy of the birthdays if that helps you. Exercise 1. Utunes, that's the cousin of iTunes. Utunes, an internet music service, offers a plan whereby users pay a flat monthly fee of $5 and can then download songs for 10 cents each. A. What are the independent and dependent variables in this scenario? Well, the independent is what changes. So in this case, the independent is going to be the number of downloads. And depending on the number of downloads, your dependent variable, which is going to be your cost, is going to change. So there's your A. B says fill in the table below for a variety of independent values. So I gave you examples of 0, 5, 10, and 20. So take a minute and pause and fill this in. Okay, now at this point, 0 downloads, so even if you don't download anything, it's still going to cost you $5. But now if you have 5, they're 10 cents each, so 5 downloads is going to cost you an additional 50 cents. And 10 would cost you an additional dollar. So add that onto your $5 and you get $6 and so on and so forth. So the 20 downloads will be $7. write an equation that models y as a function of x. So I'm hoping that you're recognizing that this is a linear function. So if we think about the formula for a linear function, y equals mx plus b, b is always where we begin, our starting point. If you're thinking about it on a graph, it would be our y-axis. And m is how we move or grow, or sometimes we even decrease. So we move, so this could be, or we increase or decrease. But in this scenario, we're going to be increasing. So our b, so y equals mx plus b, our beginning point is positive 5 because it costs $5 just to join. And for each time we download a song, it's going to be 50 cents. Oh, I'm sorry. It's going to be 10 cents. It's going to be 10 cents. So we can always give ourselves a quick check by thinking about what our table from the previous page looked like. So if you wanted to check, let's say this situation, when x is 20, y is equal to 10 cents times 20 plus 5. Y is equal to 20 times 10 is $2. So $2 plus $5 is $7, and this checks. Always taking a moment to check is always a good idea. Now it says, based on the equation you found in part C, produce a graph of this function for all values of x on the interval 0 is less than or equal to x, which is less than or equal to 40, which basically means all values between 0 and 40. Now you can use your calculator to create the table and generate additional coordinate pairs along with the ones that we found on the previous pages. So pause for a few minutes, graph your points, and then come back and we'll check it. So based on our data, at 0 it's $5. Now 5, figure how this works. This is 5, this is 6, this is 7, this is 8, this is 9. Always try and figure out what your scale is prior to graphing. So at 10, we're at $6. At 20, we're at $7. At 30, we're at $8. And at 40, we're at $9. So this is what our graph is going to look like. Exercise 2. One of the following graphs shows a relationship where y is a function of x and 1 does not. So draw the vertical line whose equation is x equals 3 on both graphs. So if you take a look at this, if you could draw x equals 3, it would look something like x equals 3 right here. Here's the line, x equals 3. Here's the line. Oops, that's not x equals 3. X equals 3 would be right here. Give all output values for each graph at inputs of 3. In other words, when x is equal to 3, what is y equal to? In this case, y is going to equal to here and here. So that's going to be positive 4 and negative 4. And here, y is equal to, right here, negative 2. Explain which of these relationships is a function and why. Give that some thought, pause, and think about that. See if you can explain why one of these is a function and one of them is not. If you take a look at relationship A, you can see how we have 3 comma 4, and we also have 3 comma negative 4. So clearly, this cannot be a function since the x repeats for different y's. And if we look at relationship letter B, we have 3 equals negative 2. Now, something to consider is if we move this around, if we took this, we're looking at A right now, and if I move this line from side to side, you can see at one point we have actually it only hitting in one spot. So some people might say, well, that could be a function, but honestly, because if you can move it and it has to hit all spots only in one. So you can see how this is clearly not a function. But now if we take a look at relationship B, if we move that from side to side, you can see how that only hits in one spot at a time. So there is a function. Well, that's it for our lesson for today. Hopefully you'll be able to define what a function is tomorrow. If you have any questions, that will be the first thing that we address in class. And you will continue doing your work in class with the help of your teams and your teacher. Thanks so much. We'll see you next time.